Okay, we've already looked at some examples where we have found the antiderivative when we were given a list and just took the derivative of those functions. This time we are trying to find the antiderivative, evaluating this indefinite integral by using our own knowledge of the derivative rules. So here we're looking for the integral of sine x dx, so we are looking for a function that when we take the derivative of it, we will get sine of x. Since we know that sine is a trig function and the derivatives of the trig functions are related to each other, sine and cosine in particular, we're going to go ahead and just make a guess here that if we take the derivative of cosine, that we'll get sine of x. But that's not right. We get the negative sine of x. But this is a good guess as our antiderivative because we know sine and cosine are related through derivatives. And the way we're going to fix things here is we're going to use the constant multiple rule from derivatives, and we're going to just double check. If we do the derivative of negative cosine, that's going to give us negative of negative sine x. That is our constant multiple rule. And so the negatives cancel out and give us positive sine x. So the antiderivative here, the indefinite integral here, is going to be negative cosine of x, and then plus c to make it the most general possible antiderivative, to give us all those possibilities. So our antiderivative is negative cosine x in this case. All right, now we're going to move on to our second example here. So our next example, we have the integral of 3x squared dx. And we have a polynomial here, the 3x squared. So we want to be thinking about the derivative rules that apply to polynomials. Particularly, let's think about the power rule. And with the power rule, we know that we want to bring down the power and then subtract 1 from the power. So here, when we've got x squared, we want to think about that as being the result of a derivative. So if that is the result of a derivative, we want to guess here something that is 1 power higher. So let's try x cubed, and we're going to take the derivative and see what we get. And when we take the derivative of x cubed, we get 3x squared. So in this case, our very first guess is the antiderivative. We don't have to do any adjustments. So the integral of 3x squared dx is equal to x cubed plus c. All right, on to our next example. So for our next example, we're looking at the integral of secant squared of x dx. And again, this is a trig function, so we want to be thinking about the derivatives of trig functions, because we're looking for a function we took the derivative of that would give us secant squared. So let's just quickly write down our trig derivatives so we remember. The derivative of sine is cosine. That's not going to be it. The derivative of cosine is negative sine. That's not it either. The derivative of tangent is secant squared. So right there, what do we take the derivative of to get a secant squared? It's tangent. So the antiderivative of secant squared is tangent x plus c. All right, on to example 4. For example 4, we have the integral of 1/2 dx. So here we're going to make a guess again, but what we get in this case after taking the derivative is just simply 1/2. So we want to think about what we could get. And in this case, if we take the derivative of something times x, it's using the constant multiple rule again, we're going to get the something times 1. So here, our antiderivative is just going to be 1/2 times x plus c, and that is because if we take the derivative of 1/2 x, we get 1/2. All right. Now we are ready for the next example, but I have to erase to have space for the next example. Alright, and now we are looking at number 5. This is the integral of e to the x dx. And what we're trying to find here is the function we would take the derivative of that would give us e to the x when we take the derivative. And we know that taking the derivative of e to the x would give us e to the x, so definitely we want to be thinking along the lines of something involving e to the x, and in fact, in this case, it will simply be e to the x plus c for the antiderivatives, because the derivative of e to the x is e to the x. One of the nicest functions we could possibly have. Alright, next example, integral of cosine x dx. Again, we are thinking about a trig function. We want to know what do we take the derivative of in order to get cosine x. We know derivatives of sines and cosines are related to each other, so we're going to guess that it's got to be a sine or a cosine. So we're going to try the derivative of sine, and we get cosine on our first guess. No adjustment is needed here, and so our antiderivative of cosine x will be sine x plus c, because the derivative of sine is equal to cosine. All right. Now for our next example, we're looking at, marker's not working very well, the integral of 1 over 2 root x dx. And for this one, we really want to think about the derivative of the square root function. We've looked at this in more than one format, but the format where we have square root of x and take the derivative and get 1 over 2 root x is the format we want to keep in mind here, because 1 over 2 root x is what we get when we take the derivative of square root x. So when we look at the integral of 1 over 2 root x dx, we're looking for the function we took the derivative of in order to end up with 1 over 2 root x. So that means in this case the antiderivative we're looking for is square root of x plus c. And we need to have the plus c every time we're finding the antiderivatives. And then last example, we have the integral of 100x to the 99th dx. And with the integral of 100x to the 99, this is a polynomial, so we want to be thinking about polynomial things and the power rule, because that is how we find the derivative of a polynomial term. And whenever we take the derivative of a polynomial term, when we do the power rule, the exponent goes down by 1. So we want to think about something where the exponent is 1 higher. So we're going to guess x to the 100th. We're going to take the derivative of that and see what we get. And the derivative of x to the 100 will be 100x to the 99. So the antiderivative we're looking for here is x to the 100 plus c. There you go. The marker's not working very well. And that's our first set of examples.